Hello everyone. So as part of a machine learning course, we've done a project called a comprehensive approach to content recommendation. So our objectives are clear cut. We've developed a content based recommendation system tailored for entertainment industry. We aim to boost user engagement and facilitate content discovery, helping content providers make informed decisions. The motivation behind a project stems from three key challenges. Those are information overload, user engagement and satisfaction, and revenue prediction. And our literature survey included several key studies, each contributing to the foundation of our project. Those are we analyzed content based systems that recommend movies by genre correlation, which showed promising user ratings. We delved into personalized system using advanced techniques like LSTM, CNN, which are adapt to recommending highly rated movies to users. Lastly, we looked at comprehensive research on rating prediction algorithms that combine random forest and matrix factorization techniques for enhanced precision. Our system architecture is a meticulous design that ensures a seamless interaction between subsystems. It starts with data preprocessing, where we cleanse and normalize the data, followed by feature extraction. We and as part of the modeling stage, we employ BERT and XGBoost algorithms for robust predictive analysis. The evaluation stage uses metrics like RMSE, MSE, MAE, and R squared to ensure accuracy. Post evaluation, we deploy our models and ensure they are maintained with continuous performance monitoring. Our methodology follows with the CRISP-DM framework, ensuring a structured approach to our data-driven project. We began with a thorough business understanding, then moved to data understanding and preparation, involving cleaning and normalization. The modeling phase was about building a content-based model and predictive models for revenue prediction. For evaluation, we relied on robust metrics to assess the model's performance. And finally, deployment was about making the model accessible through a user interface and ensuring its performance meets our high standards.
The dataset overview, our dataset consists of two different CSV files, which was one for movies and the other was for credit. So the movies dataset contains 20 features with 4,800 instances, and it has columns like movie budget, genres, keywords, and the language of the movie. And the credits dataset contained 4 features with 4,800 instances. So we merged these two datasets for our project. And the ABT representation of our project is like we have so many raw features where we converted JSON values into certain columns or list, and we derived few features like example for project profit margin. Sorry, for profit margin we have actually made use of two different columns to get the profit margin, which we are further going to use in our revenue based recommendation, and we changed the release date into datetime format, and again we extracted the year to do the year analysis in the revenue budget. And there is no such target feature for our for our project, so it's depending on the predefined target feature, and it aims to provide a user a greater control over content choices and deliver more dynamic and user centric experience. So as part of our EDS, we have performed few on the data sets to understand what our data set is and how and where it stands. So for that, for checking for outliers, we used blocks plots, and for us checking the correlation between two columns, we used a heat map. And you can see that we are displaying the top 10 most popular movies which are present in our data set, and we see Minions as the top movie. And we created a time series analysis of movie revenue and popularity over time. So the data set consists of data from 1920 to 2020, but you can see that there is a drastic increase in the popularity and as well as the revenue over time. And we were trying to explore relationship between the vote average and runtime of the movies. So here we see few values at 0 which are false data, but the overall plot we can see the maximum vote range is around 8, and few movies have the rating around 10, and the average runtime is between 100 to 150 minutes. And the scatter plot between revenue and budget, we can see a positive correlation. As there is increase in the budget, the revenue is increased accordingly. And for the bar graph, we are displaying top 10 journals. So we began by combining all the journal lists into a single list to ensure each journal is considered. Then we created a Panda series to count the occurrences of each journal and identify the top 10 journals with the highest occurrence. And we see drama as the highest journal.
Now to the modeling part. Content-based filtering is a recommendation system technique that suggests item to the users based on the features and characteristics present. In our case, it is the movies. The key component of content-based filtering includes descriptive features and then calculating the similarity between the movies and recommending movies with the high similarity score. It relies explicitly on the features of the movie's dataset, making its recommendations more interpretable. What you see is a sample of the features in the movie dataset, which is a concatenation, which we later concatenate at the overview, genres, and the keywords. Cosine similarity is a metric for measuring likeness between two movies. Each movie is a feature vector of attributes, overview, keywords, genre, and title. BERT is a natural language processing model developed by Google. BERT understands the context of language by considering bidirectional relationship between the words in a sentence. Traditional NLP models processes text in a unidirectional manner. BERT has been pre-trained on a vast amount of diverse textual data. The movie recommendation system process begins with the user embedding transformed into numerical representation. Simultaneously, each movie undergoes a movie embedding, converting its features into a corresponding feature vector. BERT model is then applied to encode the textual information associated with the movie, enriching their feature representation. The next step involves calculating the cosine similarity between the user embedding and the movie embeddings. This similarity metric measures the alignment between the user preference and the movie features. Higher cosine similarity scores indicate a greater likeness. Finally, the system generates a recommended movie based on the highest similarity scores, providing a personalized suggestions that closely matches to the user preference and interactions. As you can see, is in the sample, we have recommended movie for The Dark Knight. You can see the recommended movies along with their similarity scores.
Now I'm going to come to the revenue prediction part of our system. Here you can see the overall overview of our system. So in the feature selection, we have checked correlation for revenue with all other numerical columns, and we have found the word count, popularity, runtime, and release year and budget to be the most correlated. So we have used these as our input modules. And with these, we have used the models such as linear regression, k-nearest neighbor, decision tree regression, gradient boosting, XGBoost, random forest, and AdaBoost. So some of the models include, for example, linear regression works in such a way that it fits independent variables in a matrix, and it fits them into a linear equation to find out the relationship between them. The KNN regressor, for example, predicts label of a data point based on its neighbors. And the random forest, which is quite popular, constructs multiple decision trees, and it takes average of the output from all the decision trees. And coming to our main model, the XGBoost model, it is a supervised learning model which predicts the targets by combining estimates of a set of multiple decision trees. It is accurate, and each tree corrects the errors of the previous ones. So here, as you can see, we have divided our method into training, validation, and testing data, and we have given it to the following regression models. So after that, we have used the evaluation metrics of RMSE, MAE, and R-square score, and we got very high error scores. So for that, we resorted to hyperparameter tuning. Here we have used these parameters, which are learning rate, which is basically the step size of each iteration, the minimum child weight, which specifies the weight of each child, the maximum depth of each tree, and number of trees in the model, and fraction of the subsamples used. So these were the best parameters which we have found after 4 iterations. After inducing these parameters, we have found the scores to be in such a way. Here, we have selected XGBoost to be the best model after considering all the overfitting and underfitting issues and the train and validation scores for the model.
So basically, our deployment was developed and trained in Google Colab, leveraging comprehensive Kaggle dataset This environment enables us to utilize robust computational resources and access a wide range of tools necessary for our project. For the user interface, we choose the Streamlit framework. This includes searchable drop-down feature, making it easy for users to find their preferred movies. For our backend, we used Python. Please switch to next slide. Yeah. Our system is designed with scalability, keeping in mind it's capable of handling an increasing user base and growing volume of data without compromising performance. So next, we do have a snapshot of our GUI. So in the first, we have selected riding in cars with boys. So it will recommend the list of 5 movies the kids are all right, Seven Son and etc. So for next conclusion part, and we will demonstrate our deployment in the last.
So in conclusion, we can see that BERT can potentially offer more comprehensive understanding of a relationship between words and phrases. It provides a more enhanced understanding compared to the traditional NLP models. Our revenue prediction model cumulated in identification of the XGBoost as the optimal model, demonstrating superior accuracy and efficiency in forecasting future revenues. In limitations and future scope, we performed BERT model only on a small subset of data set. In the future, we would like to perform it on the entire data set. And we plan to expand the project to include music and TV shows as well, and integrate it with the social media, and to allow more of a collaborative and hybrid filtering system. And also continuous improvement to our revenue prediction model in terms of the hyperparameter tuning, so that it can further align with our business needs. And now for the demo.
Yeah, so let me share my screen.
We want to demonstrate how our prediction model works. So as you can see here, we have given new inputs such as budget, new popularity, and the release year. And once we run the code, we get a prediction stating the revenue after scaling down format.
So let's start with our deployment part. So this is our execution file, which will execute to show our GUI and run our models. So let's run Streamlit app. It will open GUI. Yeah, see, so this is our movie recommendation system GUI, in which here we can see the drop down for the list of the movie. As we select here Man in Black 3, then it will recommend the list of movie. As you can see, True Lies, Red, AI Origins, Copy, Lithon, the shipping news. So this is what about our deployment part. Thank you.